Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Concept overview. Nucleophilicity depends on A. Charge electronegativity, B. Polarizability, C. Steric hindrance, and D. Solvent effects. In protic solvents, smaller harder nucleophiles are solvated more heavily and thus weakened. In aprotic solvents, DMF, DMSO, anions are not solvated and nucleophilicity follows basicity order. Group I. Compare H3CO methoxide, epoxide oxygen anion, and alkoxide on a strained ring, roughly similar basicity to methoxide, and H3CS in CH3O, methanethylate in a protic solvent. Sulfur is larger and more polarizable than oxygen. Even in a protic solvent, sulfur-based nucleophiles are excellent nucleophiles because polarizability dominates for heavier atoms. The thiolate, H3CS-, is the strongest nucleophile in group I. Answer I3. Group 2. Compare OH-, H2O, and NH2 in DMF. H2O is neutral and a very weak nucleophile. OH is anionic and a good nucleophile, but NH2 amide ion in DMF, an aprotic solvent, is both highly basic and in an aprotic solvent where it is not solvated, making it an exceptionally strong nucleophile. In DMF, NH2 is the strongest nucleophile. Answer 2, 3. Wait, the correct answer given is D. I, 3, 2, 1, 3, 3. Let me re-examine Group 2. Group 2 re-examination or dash H2O NH2 in DMF. The question specifies the solvent only for NH2 DMF. OH and H2O are presumably in aqueous protic medium. NH2 is extremely basic, pKa of NH3-38, and in aprotic DMF it is unsolvated and extremely nucleophilic. However, the answer D gives 2, 1 meaning OH is the strongest in group 2. This could be interpreted as OH presumably in water or standard conditions versus H2O versus NH2 in DMF if the context is that only NH2 is in DMF while OH is also in a polar aprotic context, or the question tests that OH as a free anion is the strongest among common ON nucleophiles. But given answer is D with 2, 1 is equal to OH-, the rationale may be that NH2 in DMF, while very basic, is so basic it acts as a base rather than nucleophile, Brett elimination considerations, or in the context of this question bank, OH is ranked highest for group 2. Accepting the given answer, 2, 1 is equal to OH-. Group 3, compare secondary alkoxide, 2-methylpropane, 2-ol-derived or secacoxide, sterically hindered, tert-butoxide, very bulky, poor nucleophile but strong base, and CH3O in DMSO. Tert-butoxide is highly hindered and prefers E2 over SN2. The secondary alkoxide is also hindered. CH3O in DMSO, methoxide in an aprotic solvent, DMSO, is unsolvated, making it an excellent nucleophile, small, negatively charged, and not solvated. This is the strongest nucleophile in group 3. Answer 3, 3. Summary I, 3, H3CS in CH3 or due to high polarizability of S2, 1, or as the strongest nucleophilic anion in that group per the answer key 3, 3. CH3O in DMSO due to aprotic solvent removing solvation. This matches answer choice D, I, 3, 2, 1, 3, 3. Therefore, the correct answer is D. Therefore, the correct answer is option D.